All right, let's start by going over some of the mechanics of logistics of taking this exam. You're going to want to bring pencils, pen possibly, a calculator with you. You want to take your 2 A4 sheets of paper. Make sure that your name is clearly marked on both sides of both sheets, regardless as to whether or not you have writing on both sheets. And make sure it's clear, it's obvious. When you hand all of your papers in, make sure that the proctor writes your name in big letters across the front of each A4 piece of paper. Big letters. Make sure, this is very important, make sure you put your name on all 3 pages of your answer sheet. It's going to be 3 pages. 1 through 40, and then the next page will be 41 through 80, and then the next page will be 81 through 118, 120, 118. So make sure you have your name on all 3 pages. Make sure you put your name on the cover sheet, although just do it. And start studying right away. Some people who didn't do the review sheets, that, the first review sheet is required, and people who didn't do that failed. Some people that didn't do it failed. But it certainly affected their grade by sometimes a whole letter grade, depending. So start studying now, and let's begin, okay? Excuse my cold, but there's not much I can do about it. So let's start studying. Let's start reviewing. It's 118 questions. Okay, 2 forms, 118 questions, and a lot of numerical responses. The multiple choice, the matching, let's see. Matching is 1 through 16. Multiple choice is 17 through, this is Form A, Form B is rearranged. Then it would be 17 through 93. And then there are numerical responses where you have an individual number, no big deal. Would be 94 to 118. All right? So let's start. Okay, we're going to start out with 2 matching sections. That's going to be 1 through 16. So there's 16 matching to answer my question from before that I was thinking about. I'm in period. I guess we don't have periods, right? What period is this? This is section 3. What period is it? KL. This is KL. All right, so the 16 matching. So electronegativity, ionization energy. So I think that's chapter 6. There's a chapter 6 matching. And then there's a bonding matching. Polar bond, hydrogen bond, structural formula. So that's chapter polar bond. So that's chapter 8. There's a chapter 8 matching. So there's a chapter 6 and a chapter 8 matching. Okay. And then the multiple choice goes back to, now remember, I'm looking at Form A, where it starts, the multiple choice starts at the beginning and then goes to the end. So 17 and 18, I have, you got to know accuracy. If you look at a value from an instrument, what determines the accuracy? Well, it's the number of significant figures. So if something has 30.0 or 30, both are mathematically equal. They're both equal to 30, right? But the one with 30.0 would have 3 significant figures. That would be more accurate. Okay, then it says how many significant figures are in a value, so you have to know how to identify significant figures. So if I have something like 0.00004, how many significant figures is that? Anybody? That's correct. 1 significant figure. They are on fire today, I'm telling you. Okay. And here is excellent. Neve is here. Excellent. Welcome, Neve. How are you?
I'm fine.
All right. I don't know where I was. However, and then I guess I only have a few questions from Chapter 3. Just 3 questions, looks like, so far, in terms of multiple choice. And then there's a density problem where you're calculating either volume, mass, or density. And now we're going into some scientists. So let me just give you some names: Dalton, Democritus, Thomson, Millikan, Rutherford. You have to know those guys. Chadwick, Goldstein. I don't know who that is, but maybe I do. I don't know. Hint. I don't know. So you got to know some scientists. A few questions on that. And now remember, Chapter 3 is going to be essentially very basic structure of the atom: protons, neutrons, electrons. How do you write the symbol for tritium, for instance? Tritium. Tritium is one of the isotopes of hydrogen. Remember what an isotope is? An isotope is the number of protons are the same, but the number of neutrons vary. So the mass number varies, but the identity. So tritium would be on the left side. So you write your symbol, right? H, because it's a, right? And then you write on the left side of the symbol, you write a superscript, would be 3, because tritium is artificial. You'd write a 3, not because it's artificial, it's just on the side, artificial. So you'd write a 3 because it has a mass number of 3, and below 3 you'd write 1 because it is hydrogen. It says, which of the following is necessary to calculate the atomic mass of an element? Well, now remember, the atomic mass, if I look at a periodic table and I see that it's 1.0000008, why isn't it going to be a mass number? So I need a mass number in order to, why isn't it a mass number? So what do I have to do in order to figure out if something's not a mass number? I said, well, what do I need? Well, you're going to need all the masses of the isotopes of the element. You have this certain number of isotopes, and then you need the mass of those isotopes. So, for instance, there's 3 isotopes of carbon: carbon 12, carbon 13, and carbon 14. Now, if I take each of those and I look at the percent abundances, then I can come up with a average atomic mass. So when you say atomic mass, it's really short for average atomic mass. Let's say I have 10 atoms of hydrogen. I have 7 protium, 7 hydrogen 1. I have 2 hydrogen 2, that's deuterium, and I have 1 tritium. All right, so what's the total mass? Well, the total mass would be 7, because 7 times 1, right? And then deuterium is 2, so that's 4. So that's 7 plus 4 is 11, plus 3 would be 14. So what would the average mass be? So 14 divided by 10 would be 1.4. Well, that's obviously not the mass of hydrogen, but I'm just making this up. It's more like you'd base it on more like 10,000, the percentages, etc. But that's how you do it. In other words, you add up the total mass. What's the total mass? Then divide it by the number of atoms. Usually they work on percent abundances, so you would divide it by 100. Okay, let's see, what else? The Bohr model of the atom you need to know. You need to know the shape of the 3p orbital, atomic orbital. That's obviously a dumbbell. So what would the total p orbital be? The total p would be 3 dumbbells all oriented mutually perpendicular. So if you think of it as 2 like a cross, and then 1 going through that cross. Like if you could write it on the front board, you'd write a dumbbell above, going vertically, one going horizontally, and then one coming through the board. Okay? Now, we're going to look at, it's going to be some quantum mechanics. How many orbitals are there in the p subshell? How many are there in the s subshell, the d subshell, etc.? How many can you fit in each shell? Now, when I say shell, I mean, for instance, there's 3 shells in the p. There's 5 shells in the d. There's 7 shells. And in each shell, you can fit 2. What is the relationship between high and low energy relative to the proximity of the electron and the nucleus? If something is high, if an electron has high energy, it's going to be far away from the nucleus. If it's going to have low energy, it's going to be close to the nucleus. Let's take a quick break. Stars here. We have Noor and we have Victoria are coming to listen more attentively. Excuse me. Yes, I sound miserable and I also feel miserable. All right, so let's say what I do with the electron configuration, like how many unpaired electrons are in the electron configuration. How many unpaired electrons are there? Now, I'm talking about also with the exception. If I have the exception, remember we looked at chromium and copper, the exception. So in other words, chromium is 4s2 3d4, right? So because it's near half filled, it takes one of the 4s and brings it into the positive 2 m quantum number, and it leaves, so then it would be 4s1 3d5, so there'd be 6 unpaired. But unless it says that, you'd have to assume other than that. In other words, it says, let me read this one. It says, how many unpaired electrons are in a sulfur atom? Let's make sure that I'm doing this correctly. Are in the sulfur atom. So that would be 2. Sulfur would be, sulfur would be 3s2. So you'd have 2, right? Sulfur would be 3s2, 3p4, right? Is that right? Yeah. So you'd have 2 unpaired, right? 2 unpaired electrons. So that would be C. That would be 2 unpaired electrons, right? Let's make sure that's correct. Yes. I was just wondering if they meant the hybridized state. No, that's right. And then it says, which electron configuration of the 4f energy sublevel is most stable? Well, I'm not even going to tell you what that is. You have to tell me what that is. I'm not going to give you an answer for that. And then we look at electromagnetic radiation, high frequencies, lowest frequencies. We look at ultraviolet light rays versus gamma, microwaves, X-rays. We look at what is the emission of light from an atom. When does the emission of electromagnetic radiation occur? Remember, electromagnetic radiation is light. It's light. Okay. All light comes from those sorts of something with the atom. What is it? What occurs that produces electromagnetic radiation? You got to know that. That's a question. I'm not telling you everything. Okay. Electron transitions, but don't tell anybody. Okay. And then it says, let's see, we have to look at, like I'll give you an element. For instance, I say, I don't know, lithium, and then I'll say, so many protons, so many electrons, which one is correct? For instance, I say, in which of the following sets of symbols of elements the number of protons and the number of electrons are given correctly? Now, notice I say, if I don't say it's an ion, or if I say it's an atom, then it's going to be ground state, right? If it's an ion, then I'd have to say an ion. In other words, if I say to you, what's the number of protons, electrons for lithium? Well, there's atomic number of 3, so its number of protons of 3, so its number of electrons would have to be 3. So you're assuming ground state, unless it says specifically that it's an ion, right? Because an ion's not ground state. An ion is reactant state. Okay? And then it's more assuming electron configuration, noble gas configuration. We don't say the O word, the Voldemort word. We don't say Voldemort. Oops, I just said it. But we don't say the Voldemort word. Electronegativity. What's a valence electron? And where do valence electrons come from? What, are they D? Are the D electrons? Are those the ones that are valence? Is it the Ds, the Fs? Which ones are valence electrons? S's, P's, D's, or F's, etc. If I asked you aluminum, how many valence electrons does aluminum have? Victoria. Yeah. Oh my God, she's shocked. No, not me. No. Well, look, it's in group 13, so it's going to have 3, right? Aluminium, yes. Aluminium, yes. They have 3. Yeah, 3. Right. Exactly. All right. So more electron configuration. Now we're getting into ions. For instance, what is going to be the charge if potassium reacts? How many electrons are in the valence shell of potassium? 1. All right. So how many does it have to get rid of to be like the nearest noble gas?
1.
It has to get rid of 1. Okay. So what would its charge be? It would be, it's not accounting, it's charge. In other words, you're getting rid of 1. No, it's not -1. It's +1 because you don't change the number of protons, you just change the number of electrons, right? So if it has equal number of protons and electrons, it's neutral, it's 0. But if I give away an electron, I have an excess positive charge, right? Some more electron configurations. What 2 ways does an ionic solid conduct electricity? In what 2 ways can an ionic solid conduct electricity?
Is this one it's talking about states?
Yeah, but sort of. States would. Yeah.
Water?
Well, no, that's not a state. Well, I suppose it's a state. It's a physical state, I guess, sort of. Some people would argue that it's a chemical change, but you dissolve. In the dissolved state, it can conduct electricity. Or in the molten, if I melt it, it can conduct electricity. If I melt it or I dissolve it. Hybridization, we already talked a little bit about hybridization. No, we didn't. For instance, carbon's the big guy. Carbon is 2s2, 2p2. So you want to look at, it would be you take one of the 2s2s and you'd bring that over to one of the p shells. So you'd get 2s2, 2s1, and then 3p3. But this is why it hybridizes. That's not necessarily hybridization. The reason it hybridizes is the energy levels equilibrate. In other words, that 1s and the 3 p's are at the same energy level. So it's that new subshell. It's a new subshell. It's not S. It's not P. It's sp3. It's the same energy level. Okay. It says, it asks you for what's the configuration for the correct arrangement of the 4 valence electrons of the carbon atom in the molecule methane. Okay. Diatomic molecules, which normally in reacting, there are certain gases that form double bonds, or triple bonds, or single bonds, or are diatomic. So which ones are they? Well, nitrogen, remember, nitrogen forms a triple bond. All the halogens form single bonds, like Cl2 is chlorine, single bond chlorine. Oxygen is oxygen, double bond oxygen. Nitrogen is nitrogen, triple bond nitrogen. So we're getting into a bit of chapter 8 here. You got to know what a sigma bond is. What is a molecule with a single covalent bond? You got to know. Now this is confusing stuff, and I did this on a video. I'm going to give you a suggestion. There's a video I did, actually more than one video, on hybridization. In other words, sp, sp2, sp3. sp, sp2, sp3. You've got to know those hybridizations, and then you've got to know what a pi bond is versus a sigma bond. You've got to know what the Vesper theory is. You got to be able to say to me, I'm going to say to you, well, all right, PCl5. You got to draw it out, you got to map it out, you got to come up with, okay, trigonal bipyramidal. Okay, that kind of stuff. You got to be able to do that. So get out those worksheets. Van der Waals forces, ionic solids, network solids. Okay, so this is chapter 7. What's a nonmetal? Now, this test goes with the book, and this book loves the American system. So you got to know, this is big, you got to know your A's. So 1A, 2A, that's the same as 1, 2, right? 3A is 13, 4A is 14.
Those are the groups.
Yeah, those are the groups. That's the American designation. So in other words, the B elements are the transition elements. Those are the B's, are the transition elements. So 1 is 1A, 2 is 2A, 3 is 13 is 3A, 14 is 4A, 15 is
Just like the valence thing, right?
5A. Yeah, it's just a valence, exactly. So you've got to know your A's and B's, which is pretty straightforward. And then what else? What else?
So is noble gas like?
What is it?
Noble gases are like
Noble gases are 8A, I think. I don't even know if are noble gases an A or is it just 8?
Yeah, it's
8A? Yeah, do a double check on that.
Yeah,
Is 8A? Okay, so yeah, noble gases are 8A. So the 6 columns on the right, boron, carbon, nitrogen, etc. The 6 columns on the right are 3A, 4A, 5A, 6A, 7A, 8A. Right? Okay. Then you have let's see. In which of the following are the symbol and name? All right, so you got to know some polyatomic ions, symbol and name. It's pretty easy. You can have that on your thing. Now we're looking at some nomenclature, and we're up to nomenclature. So, for instance, I'm going to give you. Let's say I give you. I give you FeO. Given FeO, what's the charge on the iron? Given FeO, what's the charge on the iron? Well, there's one oxygen, right? And oxygen is always -2, right? So remember, the cation has to be equal and opposite. Then there's only one oxygen, so it's going to be -2. So equal and opposite is +2. Well, there's only one iron there, right? So each iron must be +2. So it's got to be iron 2, iron +2, right? Okay, those sorts of questions. If I give you a cation, say manganese 4, and I combine it with oxygen, what's going to be the formula? Manganese 4 with oxygen. Well, MnO2. Manganese 4 oxide would be MnO2. Okay? Let's take a quick break, and then we'll be back. Actually, let's finish this page. Okay, which of the following? Okay. And then I'm going to give you a name. Let's say I give you sodium sulfates. I'm going to have to recognize the chemical formula, okay? All right, let's take a quick break. All right, I'm going to give you a hint on this next one. Sulfur hexafluoride. Just a hint. Okay. So there's some acids, bases, well, not bases, but some acids you have to know. Some Greek prefixes you have to know. Now we're going to get into moles here. All right, so you've got to know how many atoms there are in a mole. Right, so if I have a mole of sodium, mole of Na, I have 6.02 times 10 to the 23rd, right? If I have a mole of water, mole of H2O, I have, how many you said? It means I have 6.02 times 10 to the 23rd particles of water, right? What happens if I have a mole of water? How many atoms are there? Well, it's H2O, so it'd be 3 times the mole, right? Okay, so you got to read the question. So you need to know moles. It's just a number, like moles of molecule, 6.02 times 10 to the 23rd. You need to know if I have 2 moles, I have 2 times that. You need to know 1 mole of any gas at STP has a volume of 22.4 liters. You need to be able to do density. So if I have the density of an unknown gas and I want to find the molar volume, the molar mass, I have to know how to do that. Well, the mole of a gas is given in grams per liter. That's what the mole of a gas is. So if I have the density of a gas, right? So let's say it's 5 grams per liter, right? So how would you get the molar mass of that gas? Well, it would be 5 grams per liter equals 5 grams per 1 liter equals X grams over 22.4 liters. Because remember, it's the molar mass the molar mass is 22.4 liters. So if it's 5 grams per 1 liter, and then you say equals X grams, the molar mass, over 22.4 liters. Now you can ask me to do a question like that, maybe the next class. So you have to be able to do, you have to know the relationship between molar mass, moles, and liters. Now, let's see, what else do we have? We have percent composition. So if I have aluminum pyrophosphate, what percent of aluminum pyrophosphate is aluminum? So I have to write down Al4 in parentheses P2O7 3. So I'd have to get the total mass of the particle, right? The total mass of the particle, and then divide in the numerator the total mass of the aluminum divided by the total mass of the particle times 100. The total mass of the phosphorus, so it'd be 2 phosphorus times 3, so it'd be 6 times 31, divided by the total mass of aluminum pyrophosphate, etc. Okay, times 100. And then you need to know coefficients, like if I have a very simple equation, like I have to be able to balance it. So balancing very, very basic equations, extremely basic equations, is going to become very important. N2 plus H2 yields NH3. Very basic equation. You have to be able to balance it. There'll be a single replacement reaction that you have to balance, but that's pretty easy. You have to, in order to predict whether or not a single replacement reaction takes place, you need to consult a chart that shows the activity series of metals. So just remember the activity series. Write that in your notes. You have to know what a oxidation reaction is: single replacement, double replacement, synthesis, decomposition. What's the conservation of mass relative to chemical equations? We have, let's say I have a reaction. 2H2 plus O2 yields 2H2O. Right? So I say to you, all right, how many moles of hydrogen react with 2.4 moles of oxygen? Well, 2.4 times 1 equals 2.4. So 2.4 times 2 equals what? And then 2.4 times 2 equals what? That would be for the water, hydrogen and water. And now I have, let me read one to you. Iron 3 oxide is formed when iron combines with oxygen in the air. How many grams of iron 3 oxide are formed when 16.7 grams of iron, Fe, reacts completely with oxygen? And they give you the stoichiometric equation, which is quite nice of them. 4 Fe plus 3 O2 yields 2 Fe2O3. So what I like to say is you write your stoichiometric masses above the iron, the oxygen, and the iron 3 oxide. And then you say to yourself, well, I'm calculating the product, so that's Fe2O3, so I put an X under that, and then I put 16.7 under the iron, and I say to you, right, iron, 4 Fe's divided by 2 Fe2O3's yields, and then I put, well, what is the mass of 4 moles of iron divided by what is the mass of 2 moles of iron 3 oxide equals 16.7 grams of iron over X grams of iron 3 oxide, and that would be your answer. Let's take a quick break. So I do that a few more times, but what I also have to do is I do limiting reagents, and I do excess reagents, and I do percent yield, and that's it. That's it for the multiple choice section. And now I do numerical responses, which is just based on what we did. For instance, I'll read you the first numerical response. How many protons are present in an atom of Be9? How many protons are in Be9? Okay, well, you just look up beryllium. I mean, it's no big deal. You look up beryllium, so you don't even need that. Beryllium has an atomic number of 4, so it's 4 protons. So I do atomic theory, protons, neutrons, electrons. I do that, and then I do electrons. That's like I do 1, 2, 3 charges, electrons. I'll do those. I'll do like 6 quantum mechanic things, some simple stuff. How many valence electrons are in blank? How many valence electrons are in blank? What is the charge of a particle having X number of protons and X number of electrons? Valence electrons for an element. Covalent bonds. So we're getting into, it says noble gas electron configuration. All right, I'll just read it. I'll read the middle one. How many electrons does a nitrogen atom need to gain in order to attain a noble gas electron configuration? So we're looking at bonding for the free response. Bonding, bond angles. What's the bond angle of water? Cations. What's the charge of a cation? How many manganese 3 ions are needed to form manganese 3 oxide, for instance. You got to be able to determine the subscript. So the free response really, or the numerical response really, is chapter 3, 4. I don't see a lot of 5. I see 8. I see 8. I see 9. I don't see a lot of other things. How many electrons? How many valence electrons? What is the coordination number? I guess that's chapter 7. How many valence electrons are here? It was the total number of covalent bonds. That's chapter 8. How many electrons does? How many unshared pairs are there? How many covalent bonds are there? How many unshared pairs are there? What is the bond angle? What is the cation of this molecule, of this substance? All right, and that's it. Good luck. Good luck. If you study, you'll be fine. It's pretty generic. The only thing that's new, some of the stuff that's new, is chapter 10, 11, and 12, although we spent a lot of time on it. And the last class, the next class, I'll do a little stoichiometry. Okay, I think that'll be good. All right, so this is your first semester exam review, right? Nora's looking at me very intently. Excellent. And, just come well rested. Don't study too much. Okay? Have a good day and goodbye.